what year it is, it will be taking the best method or best practice. So let's say tomorrow Rails has a new way of deploying or building, which can be done better. So for example, in the first version of Otto, they use Vagrant. It's very slow to build an image because you have to build it in AMI. But in the next version of Otto, I think the 0.2, they will actually utilize Vagrant's layering capability. So you should be able to create an image much faster, right? So it sort of gets better as it goes. At the moment, it's not ready for production. From what they say, wait for at least 0.3. I think that one is probably earlier next year. 0.2 is not out yet. But again, basically, you don't have to know the nitty-gritty. Somebody has already sort of thought for you the best practice for your type of application. So again, in this case, a Rails application is suitable because if we, from what they study, most of the Rails application, other than minor tweaks, actually are mostly the same, right? So why everybody needs to learn all this, the best way to do the best practice, when actually in here, Otto, for example, things like production deployment, we'll see later, but actually an engineer who has worked with AWS in their core engineering has actually designed sort of a cluster type of deployment script, which basically any new developer can actually utilize without needing to know the nitty-gritty. Right, so it's as easy as just saying auto dev to set up all my dev environment. Just like in Vagrant, you just say Vagrant up and you have your environment ready. And then when it's time to deploy, you just say auto deploy. All your different backends will be ready and easily managed, right? So it's all automated development environment. Right. So next step, I'll actually go through each of the steps of your sort of application work cycle, and we can drill down a bit if you want, or probably we'll just go a high level thing, and then later on you can ask me if you have any specific questions. Right, so in the development stage, they are still utilizing Vagrant, but actually is under the hood. Right, so when you have a new application, like me, I was a newbie in Rails, so I just download the Rails application. What I just have to do is say auto compile, and then actually it will try to automatically detect your application. So in this case, it is a Rails, it will try to automatically detect it. In more complex deployments, I will actually have to have an app file that actually describes its dependencies. Later on, I'll show you an example of a more complex system that you want to model. So for the simple case of application, let's say like Rails, standalone Rails, I just download it, and the app file I need looks like this, which is nothing, no application needed. Just like Rails and Magic, it will detect and deploy your Rails application. And then for app file, which is more complex, so let's say a larger application where you have a few components, let's say a PHP web portion which is talking to a RabbitMQ, which is deployed on Docker, and it has a MongoDB and a Memcache. All I have to do to model it is actually quite easy. You see here, it's just saying your application and who are my dependencies, direct dependencies on your application. And then applications itself, like you see in this case here, the application type they said is a Docker, right? My application can be a Docker, it can be a normal server and system, so it doesn't matter. What is important for your application, it doesn't need to know what is the details of its dependencies. And dependencies can have their own dependencies as well. You just need to know its direct dependency graph, and it will actually build up basically all the pieces, so to ensure that they can all talk to each other. Right, so what are the commands needed in the development step? Again, very simple. You just say auto compile, download the source code, auto compile, auto dev, wait a while, the system is booted up, auto dev address to find the IP address of your application, auto dev SSH, and then you're into the system. Yeah, of course the Rails one here, it doesn't sort of auto start. I just have to do my bundle exec Rails start thing, then it's here. Right, so your sample app for the Rails is out. And then if I need stop the machine, it's using Vagrant in the background. So you just say auto dev Vagrant pulse and it will shut it down. The other command is auto dev destroy, but then if you destroy it, it takes a while back to rebuild it. So usually I just say auto dev Vagrant pulse. Right, so me coming in as a total Rails newbie, just pull the source code, I just run this command, and then the application, other than needing to start the Rails server, is actually already running. No further magic needed. Okay, so actually what happens when I do the compile, right? So remember just now when I say best practices are sort of encoded. So when I do an auto compile based on its current knowledge of the best practice for Rails, you will actually set up a sort of tree structure that describes the best way to develop in Rails, the best way to build an image in Rails, the best way to deploy a Rails application. Right? We'll dig through a bit deeper on each of the files if they are interested. But basically, the important things is there's .auto ID, which is sort of a unique identifier. Because when you're deploying it to let's say a cloud system, your application is not just made out of just one app, right? It can have multiple apps. But each app might have a dependency, let's say a database, right? So you don't want to be deploying the same dependency twice, right? So it uses this mechanism called auto ID, so that when you're deploying it to your production system, if the dependency is already there, it just leaves it there and just creates any other nodes which are sort of missing, right? And the .auto files has actually all your, again, basically all the knowledge to drive the application in all the different phases. So for development phases, you can see under the data folder, it actually stores your Vagrant VirtualBox machine. And under the dev folder, that's actually a Vagrant file. So it actually generates a Vagrant file which models your whole application in one single Vagrant file. So traditionally, when we are using Vagrant, we might to model a more complex application, we might have a few Vagrant boxes, but it eats up a bit of memory. So, but here, when it combines everything in a Vagrant file, it doesn't really tie you to a single box because when they communicate with each dependencies, they actually use the service name. Right? So when you are deploying it to production later on, because it communicates just with service name, you can easily put it on a different cluster or put it on a different server. Or you can even put it in a different region or a different provider. I can have my PHP thing on Amazon, then I can have my MongoDB, let's say, on Azure. Of course, you wouldn't do that in real life, but it can be done. Okay, let's just run through a fast one. Oops. Okay, so this is just me getting the Rails application, nothing too special. Pull out the whole thing, right? So this is a normal, the sample app thing. So you can see here, there's actually no app file or anything, it's just a source code. Right, so my Visual Auto is 0.12. Just run the compile. Oops, let me stop it. So you can see here they are compiling it. So I didn't have to tell it anything, but it actually automatically detects it as a Rails application and actually applies a simple rules. And you see here in infrastructure, they detect it as AWS simple. So at the moment, Otto has only intelligence for two versions: the simple version, which is a standalone machine, and sort of like a full cluster type machine. So, but next time I think they will come in with probably more plugin mechanism where you can have, let's say, something in between, and you should be able to customize it at the moment. But at the moment, there's no plugin mechanism. But here they actually automatically choose, unless you specify cluster, it will just put it as a simple machine. Okay, so we have compiled. So after you have compiled the thing, then you basically want to enter into your basically development mode. Okay, so just now we compiled already. Right, then it actually creates the file structures. Just now that that I showed you, basically basically encodes the knowledge of your whole applications, all its dependencies, and all the native scripts to get it into
build and deployment. Let's see. Okay, here's the Otto ID. So this unique identifier will just tell you, so we don't mix up the application when we deploy it to your cloud. Yeah, so they have a whole bunch of, it's sort of like a JSON-like kind of structure, but it's actually the HashiCorp's sort of DSL, but basically it tells you the structure of your applications. Again, you don't need to know anything about this. This one will just drive basically all the other tools in the HashiCorp's portfolio. Again, this is just showing you some of the examples. So again, imagine if I actually coming in as a newbie, I don't know anything about Terraform, I don't know anything about Packer. All this knowledge is actually encoded for me, and it is, you can say it's the best practice that they have at the moment, right? So it's actually a good starter point that I can study. Let's say I want to know more about Terraform or Packer. I can just copy this and use this as a sort of a good starting point, right? Rather than try to figure out for myself. So the .tf files are Terraform files. Yeah, Terraform. Yeah, so in all applications, how does the application know each other? They use their console product, which is basically sort of name service kind of management. So in all your application, they will usually have a console. They call it the foundation. That means they have a foundation items that handles the name service for you. Again, you don't need to know how it is set up. Just know that it will be in there, and that you are able to talk to each components just by the name. You don't need to know the IP address. You don't need to know to figure out your /etc host and things like that. It's all set up. Let's see. Okay. Yeah, so all these are just configurations which you don't really need to do anything for that. Okay, so we're done with development, right? So we have our sample application. It's up and running already. Okay, so now I've done coding. Code. Right, so now I've finished my development. So how do I get it to be deployed? So usually in best practice for modern systems, you don't push your code. Okay, back in my time, my old school, I use FTP and upload your code up. So of course, definitely don't do that. Previously, we do things like, okay, pull from GitHub your latest source code, and then you run your application. You can do that, but also not the best practice. Usually what people will do is they actually take the application, sort of freeze it, do the final test in your continuous integration and deployment stage, and then use the image to deploy. That way, whatever you test can be guaranteed to be the same of what you actually deploy to production. So, sort of HashiCorp's solution for this is to use the software called Packer, right? And then again, they safely store all the things needed to interact with your cloud provider inside Vault, so you actually don't need to, put it out in public, and it's safely stored in there. So before they can actually build your image, AMI image, they actually will boot up onto your cloud provider, again using Terraform. They will boot up the sort of the foundational dependencies. Because when you freeze your image, it has to have the knowledge like, okay, what is the IP address, or at least the name of all its other dependencies. So it will actually boot that up, and then the final product will actually be an AMI image to be stored on your Amazon. At the moment, only Amazon is supported, but next time they can easily add Azure and the other cloud providers. Okay, so just now when we went through the long steps of the passenger fusion, right? So step 4, 5, and 6 can actually be easily solved by two commands: auto infra, auto build. You actually create an image, and then the deploy is just one command, auto deploy. So I actually don't need to do multiple steps. Again, you don't need to know what's in here, and it's very blur, but basically it just shows you the Packer configuration, which again, you don't need to create anything, it's all auto-generated for you. Okay, so what does the build step look like? Yeah. Okay, so you just call auto build. So no, here, so first step to call is call auto infra. So it sets up the foundation pieces. You can see here, it sets up your console. Oh, did I do it wrong? Okay, I think it's the wrong one. No, it's compile. Sorry, wrong one. Instance build. Okay, it is build step. Yeah, so I can't really do the real-time test now. You can see it takes a while to compile. They're working to improve the speed on that.
Mm.
Uh, so they call auto infra to set up the foundational pieces. So it sets up all your VPCs. So in Amazon, you have your VPC, sets up all the routing and things like that. So you don't have to set it up, they will set it up as per best practice. And then they actually use that to build the image. It takes a while, they just let it run. Again, all these are just driven by Terraform. You don't have to figure it out. You can see here, they create the resources added. And then it creates a console node. So you run your build. Takes a while. So you build. Yeah, so you can see here they're putting all your Rails things in your bundler, fork, everything. So it basically sort of does the same steps that it uses to build your development environment, but now it uses it to build an AMI image which is frozen, so that you can then just use that image to deploy. So all your gems. Yeah, this one's your application, Micheal Hunter's application. Okay, so created. So now you have Amazon AMI waiting for you on your cloud, which you can use for your next step. Okay, let's see. Okay, so we've built your image already. Oops. Okay, so now the last step. Now we have an image, time to deploy. So again, it uses Terraform, and like I say, at the moment, Otto's intelligence will have two methods. It has a simple standalone server just for your testing and maybe your staging. And it has a high availability deployment. I think it's a bit overkill because it has like public facing load balancers and private VPCs, bastion hosts. Right, so it doesn't have anything in between. So if you do the HA deployment, it will be a bit expensive. So technically, whatever things that the Terraform scripts is generated, you can, if you know Terraform, you can actually go in there and modify it yourself. But again, like I say, as more and more version comes about, they will give you opportunities to plug in other different kind of sort of deployment. So imagine next time for your company, you just have to ask your system guys to say, okay, design for me the best structure of your system one time, and his knowledge can be encoded into Otto, right? And then next time you give it to any of your developers, again, they don't need to be system experts, but it will Otto will deploy it as per your company policy, and with the best practice. So, so again, it can be customized, but at the moment there's no plugin yet since it's so early. And of course, next time with Nomad, you can do things like auto scaling, and so you can tell it like, okay, for today I can schedule I want to have 100 node. Or maybe you can say if I'm running low on CPU, I can scale up and scale down without needing to use your how you say your vendor provider. So you no longer are stuck with Amazon's auto scaling, right? You can use auto scaling across Azure, AWS, so on and so forth. Okay, yeah. So again, for deploy, it's very simple. Just auto deploy, done. When you're done, just say auto deploy destroy. It will remove it.
Mm.
Again, here are just Terraform scripts. Again, it's too blur, but basically, whatever scripts they generate, you can take this. You can actually even modify it if you understand the Terraform syntax. Deploy. Build already. Yeah, the deploy one not that successful because I'm not a Rails guy, so you can get the system up there, but I couldn't get it running. So I'll just show you some of it. Right, so again, it just auto detects all the setup of your application, and then it will just okay, see here they already deployed. So the output in here is your URL of your system. So because you have an AMI baked in already, when you deploy your system, it's very fast. But of course, in this case, it's just a single node. So let's say you're doing a more complex application with multiple dependencies. Each of the dependencies will be baked into an AMI, and they'll be deployed in here, and they are linked together. The rest of it is not much use. Oh, done. Okay, I mean I can deep dive a bit more if you guys have any particular question, but basically it's still very new. Try to use it and give feedback. It's early enough in its cycle that it's taking feedback on best practices. So let's say you come from Node.js community or PHP and things like that. You can give them the best practice, you can tell them what is the best practice of the applications at the moment. Because HashiCorp guys are Ruby and Golang, so they know what's the best for Rails and Golang. But for let's say like PHP, they are waiting for input. So I'm trying to create something of okay, what are the best practice for PHP? But likely we will do specific things like okay, what's the best practice in WordPress or Laravel and things like that. Right? And if you're a Python person, you can say okay, what's the best practice to deploy, let's say Django. Right? So they need to know all this knowledge because all this knowledge needs to be encoded into the sort of the auto, the auto bot basically. Okay. Any questions? Yes.
You say you're not a Rails programmer.
Yeah.
So what do you program usually?
PHP. Ooh, yeah.
Yay. So so why is example you're using Rails?
Because the auto again was written by HashiCorp, so basically the best because it's so young at the moment. The one that I could get it working automatically is the Rails one. Because even like the Node.js, if you don't put I think if you don't have if the start program is not main.js or something like that, if you start it with index.js, then it doesn't work. Yeah, so at the moment, for nicer demo, I use application. So this one we can combine with Anand's work. Next time he can probably put. He can try to get Rails, a proper Rails application working in Otto, and then give feedback on what is not working or working. So it'll be good. But again, here the important thing is to see that in your more modern application, it has many different pieces. So just now there one of the participant was asking, will Rails be able to scale? But usually in bigger application, you break up your problem solution to each tools, which it is strong in, So you just break it up to your domain problems, and then if let's say certain things is better written in Java because it has some sort of libraries. Then with a tool like Otto, you can link all your different pieces together rather than try to solve your big problems with just one single tool, right? Because in any larger system, you'll never find a perfect solution, right? You just piece together, and then you can always say, when I find a better piece, I'll just take out the piece and replace it with a different solution. But of course, I agree with Anas. At the start, go fast, right? So if you know Rails and you can get it fast out, just get it up so that you can prove that your product works first. Then worry about scaling later. If you want to scale, you call me. Call me.
Are you personally on Otto already, or is it on another machine?
Yeah, just playing around with it, and I'm trying to contribute to make it better. So yeah, so I have one pull request. Yeah. Yeah, so it's very early in the code, and they are quite friendly. So and usually HashiCorp's product are quite good quality wise. It's all written in Golang, so I'm using this as a way to learn my Golang as well. So contribute. Okay, thank you.